Hello everyone, so we're going to review some AP Calculus AB, and today we're going to be looking at the derivative. Now the derivative, how you think about it, it's a rate of change, and usually it's in this format, d over dx, and then whatever you have a function here. And so again, it's the rate of change for that function, so it's like slope, but it's a tangent line to one point, so it's that slope at that instantaneous point. It could also be the rate of change of that whole function. So definition by limit. So another way to write the derivative is f prime of x. Let me move my paper over so you can see. F prime of x is equal to the limit of h as it approaches 0 of f x plus h minus fx over h, and then that's the definition of a limit. A definition of a derivative as a limit. We also have the rate of change, which you're given an interval like a, b, and so the rate of change for this would be f b minus f a over b minus a. And if this is the limit as x goes to c, then that's also the derivative c. And with this specific rule, you need it to be a continuous function on here, and that function can be derivative of in the open interval a to b. So those are two things. Okay, let's look at some derivative rules. So first, general rules are, so whenever you see these, that just means we're going to be deriving whatever's in those parentheses. And first we have cu, this is the constant one, is equal to cu prime, derivative of uv, so this is the product rule, this is multiplying, so uv prime plus vu prime. This is the constant c equals 0. You have an x, derivative of x is 1. When we have the derivative of e to the u power, is equal to e to the u power u prime. Now we get into the sum difference rules, u plus minus v, which is equal to u prime plus minus v. So basically you're subtracting or adding the derivatives of those two. Oh yeah, that's also important to u and v are functions. Sorry, I didn't mention that earlier. Okay, so if we have quotient, this is the quotient rule, vu prime minus uv prime over v squared. The next one we have is u to the n, this is the power rule, and it's n u n minus 1 u prime. And then we have ln u u prime over u. And our last one is the chain rule. This one goes f of g of x, so it's a function within a function. And this one, we're going to have to move this over like this, is f prime of gx, and you're going to multiply that by g prime of x. And now we're going to do the trigonometric functions. Again, this is your sine, cos, tangent, all those good ones. So you have sine is equal to cos u of u, multiply that by u prime. Cos is negative sine u prime. Tan is secant squared u prime. Now it's our inverse ones. CSC is equal to negative CSCU cotangent U prime. Still going. Secant is secant U tan U prime. Cotangent is negative CSC squared U prime. So our trig ones. Now we're going for the inverse trig. These, some of them are just the negative version of the other. So like arc sine is U prime 1, or square root of 1 minus U squared, but arc cos is just this, but negative. Another one that we have that case is arc tan, which is equal to U prime 1 plus U squared, and arc cotangent. Cotangent is just the negative of the arctan. Next set is arc of CSC, and that one is negative U prime over absolute value of U squared minus 1. That one, actually, this one should be arc secant. Sorry about that. The arc CSC is actually the negative version of that. So instead of a plus there, it would be a negative sign. And implicit differentiation, we could do that quickly. So dy dx, this is implicit differentiation. It's when you have something like x squared plus 2y cubed plus 39x equals 5. You'll have something like that, and then basically taking the derivative of both sides. Remember, this is constant, so it's going to equal 0. This is 2x plus 2y squared, and then the derivative of y respect to x is dy dx plus 39. And then from here, we're just going to get rid of 2x and 39 to that side, so 2y squared dy dx is equal to negative 39 minus 2x. Then here we're just going to divide by 2y squared to get dy, sorry about that, dy dx is equal to negative 39 minus 2x over 2y squared. Oops, I did that wrong. Actually, this is supposed to be a 6. Sorry about that. It's really late. And I wasn't paying attention. Sorry about that. These are all supposed to be 6s, not 2s, because we did the product rule here. Right? That's just a review. I'll make another one. Sorry about that error. Have a good day.